Hi guys! So sad that I'm away from you today, but I figured we'd try a new method of teaching, so hopefully I can teach you through the camera today. So anyway, get excited. Today we are going on a journey with Sakatoa! So it's like an Indian, so we're going on a journey with Sakatoa. So you may wonder, what the heck is Sakatoa? Well, I'd love for you to meet my best friend, Sakatoa. So I'd love for you to write this, what I'm about to show you, at the top of your page or somewhere on your notes page. So here we go. So if you can see this, there we go. All right, so sine stands for opposite over hypotenuse. So that's the sa in Sakatoa. Sine equals opposite over hypotenuse. All right. Then we go up to cosine. Oh, other way. Cosine equals adjacent over hypotenuse. All right. So cosine equals adjacent over hypotenuse. And finally, you have tangent. Other way. Tangent equals opposite over adjacent. So there you go. That is Sakatoa. Everything we do today, you will need Sakatoa for. All right. So back to your notes. All right. So the definition, that first definition that you have on your note sheet there says the sine of an angle is the ratio of the length of the leg opposite the angle to the length of the hypotenuse. So sine of A, if you look at A, you go opposite A, start with angle A, go opposite A, and you see the opposite side there is little a. All right? And then we go to the hypotenuse, which is C. The good rule of thumb there is that any time you're looking for the hypotenuse, you're going to go opposite of the right angle there. So sine of capital A is going to equal little a over C. So let's see if you can see this here. This is what your note should look like. So I'm going to leave this here for a brief second. So sine of big A should equal opposite over hypotenuse, which is equal to little a over C. Then when we go to sine of capital B, we start with B, we go opposite B to the little b, and then we find the hypotenuse, which again is C. So sine of capital B is B over C. All right, now moving on to cosine. Of course, cosine is with our Sakatoa, so cosine is equal to adjacent over hypotenuse. So when we go to cosine A, then we're going to go to the side right next to, because again, adjacent, that just means right next to. All right, so cosine of A, we go right next to A there, and you see that that's B. And then again, we go back to the hypotenuse, which of course is C. So the cosine of capital A is equal to B over C. All right, moving on to cosine of capital B is, again, adjacent over hypotenuse, but this time because we're starting at B, we go adjacent to B, which is A, and then the hypotenuse again is C. So that's why the cosine of B is little a over C. All right, and then finally, tangent of capital A is opposite over adjacent. All right, so that's our TOA for Sakatoa. All right, so we start with angle A, we go opposite angle A, and we get little a, and then again we go adjacent to big A, which is B. So that's why the tangent of A is A over B. Then finally, the tangent of B, we start at angle capital B there, we go opposite capital B there, and you'll see that that's where we get little b, we go adjacent to that capital B, and that's where we get A. All right, so hopefully you've been able to fill in this chart that I've been showing in front of my face for this whole entire time. So now we're going to use those, and again, you want to use that Sakatoa every step of the way, no matter what kind of trigonometric things you're doing. And that is a big word, trigonometric. But you can probably hear a lot about trigonometry, or you can say trig for short. All right, so let's look at example 1. It says, write the trigonometric ratio as a fraction and as a decimal rounded to the nearest hundredth. All right, so we are going to the sine of capital J here. All right, so the sine of J, we start at J, and sine again is opposite over hypotenuse. So we're going to go opposite capital J, and that's going to be that 60. And we go to the hypotenuse, again, opposite the right angle, which is 61. So it's our sine of capital J, we get that is equal to 60 over 61. And if you have your calculator, you can type in 60 divided by 61, which gives us 0.98. 0.98 rounded to the nearest hundredth there. And again, hundredth is 2 places, so that's rounded to the nearest hundredth. All right, now going on to the cosine of capital J there. So again, let's use our SOHCAHTOA. So ka, so cosine is equal to the adjacent over hypotenuse. So we go to J, adjacent to J there, you see the 11, and the hypotenuse again is the 61. So we get cosine of J is 11 over 61. And again, if we're going to use that in our calculator, I'm doing it right here with you. 11 divided by 61 is going to be 0.18. 0.18. All right. And finally, let's go to tangent of K. So the tangent of K is equal to the opposite over the adjacent. So if you start at K there and you go opposite the K, you see that that's an 11. And then we go adjacent to the K and right next to, and that's the 60. All right? So the hypotenuse always stays as a hypotenuse, even though the hypotenuse here is next to K as well. But whenever it's talking about adjacent, it's talking about one of the two legs, not the hypotenuse. So the tangent of K there is 11 over 60. Or again, if we put that into our calculator here, we get 0.18. 0.18 again, just a little bit different kind of 0.18, but it's still 0.18 when we round there. All right, so now let's move on to example 2. It says again, write the trigonometric ratio as a fraction and as a decimal rounded to the nearest hundredth. All right, so this time all they did was they flipped the triangle. That's all they did there. All right, so we start with our cosine of capital A. So cosine, again, we're going to use our SOHCAHTOA, so ka. So that's going to be adjacent over hypotenuse. So if we start at capital A there, we see that adjacent to capital A is the 24. And then we go, the hypotenuse there is 25. So the cosine of capital A is equal to 24 over 25. All right? And again, if we put that into our calculator, we get 0.96. 0.96 there for cosine of capital A. Again, that's 0.96. So the tangent of capital B, all right, so we go back to our SOHCAHTOA this time because we're using the tangent. So we're going to look at opposite over adjacent there. So opposite of the capital B is the 24, and adjacent to the B is the 7. So the tangent of capital B is equal to 24 over 7. Again, that's 24 over 7. Which if you type that into your calculator, 24 over 7, you're going to get 3.43. So again, that's tangent of capital B is equal to 3.43. All right, and then moving on to the last bit on this front page, we have sine of capital B. So the sine is the opposite over the hypotenuse. That's our SOHCAHTOA. So sine is equal to opposite over hypotenuse. So if we start here at angle B, and we go opposite of B, and we get that 24, and then we go back to our hypotenuse, which is 25. So therefore, again, with sine of B, we get 24 over 25. Okay? And again, 24 over 25 is still going to be that 0.96. Something interesting to note, you'll see that the cosine of A here is equal to the sine of B. All right? Because you'll see that cosine of A, that's adjacent over hypotenuse, is the same thing as the opposite to B over the hypotenuse. So kind of cool there. Some of these can be equal to each other. So what I'm going to do is I'm going to show you the answers here just with the fractions. I didn't write down the decimals there just to make sure that you got them all correct. So I'll give you about 30 seconds to make sure you can check your answers here to make sure that you got them all right. All right, so here we go. So hopefully you can see this pretty well. This is example 1. Okay, I'll give you about 30 seconds. Okay, cool. All right, so hopefully you got that. So flip over to the back of your page, and now we're going to start at the easiest part of this lesson. So I hope you all have a calculator. You need a calculator. Just write down. So the first thing you're going to do when you get to your calculator is you're going to push the mode button, which is that second button. It's right next to the second. So click that mode button. All right, and you're going to see something like this that comes up. All right. So you'll see down here where it says radian and degree. That's on your third row there. If yours has the black in radian, you need to switch it over to degree. Your degree needs to be lit up, which means it's in degree mode. You will get the wrong answer if you are not in degree mode. So make sure your calculator is in degree mode. All right. So once you're done with that, we're going to get out of this. So all you do is second quit there, and you get out of that. So now we can use our calculators. All right, so now we're going to find these trigonometric ratios with our calculator. This is the easiest thing ever. All you have to do is plug it into the calculator. So let's do that first one, sine of 52. So everybody type this in with me, the sine of 52 degrees. All right, so you can see that this is what I got for the sine of 52. Hopefully yours matches up with mine. All right, so the sine of 52, we're going to round to the nearest hundredth. And again, hundredth is just two places. So hundredth is going to round to 0.79. 0.79 there for sine of 52 degrees. Okay, cool. Let's move on to the next one. So type this in with me. The cosine of 19 is equal to, hopefully you got something like that. So 0.945, which is going to round for us to 0.95. 0.95. Again, that's rounding to hundredths, rounding to two places. All right, and then finally, let's do the tangent of 65. All right, and again, all those buttons that I'm clicking, sine, cosine, and tangent, they're just those buttons right there. They're two rows above your numbers there. All right, so hopefully you can see that. The tangent of 65 there, it looks like I got 2.14. So 2.14, hopefully you got the same thing as well. All right, cool. So again, let's just make sure your answers match up with mine. I'll show you what I got here. Okay, there we go. So 0.79, 0.95, and 2.14. Cool. All right, let's move on to example 3. So now we're going to use these lovely ratios with angles, with actual angle measures. All right, so let's look at example 3 there. So we got to look at what we are trying to find and what information we already have. So on this one is we're trying to find the length, and we're trying to find BC here. All right, so whatever we're trying to find, we're going to call that X. So whatever your unknown is, as always, we're going to call that X. All right, so I want you to label that under BC. I want you to label X right under BC. All right, so now if you look at the 15 degrees, you'll see that the 10.2 feet is opposite of the 15 degrees, and then your X there is just adjacent to that 15 degrees. So that means we have an opposite and an adjacent thing that we can use to solve. So if we think back to our SOHCAHTOA, which one uses opposite and adjacent? Well, let's think sine uses opposite and hypotenuse, so it's not that one. Cosine uses adjacent and hypotenuse, so it's not that one. So it must be tangent, because that uses opposite and adjacent. Cool. So now that we've figured out that we're going to use tangent here, we do the tangent of the degree that we have. So tangent of 15 degrees is equal to our opposite. So we're going to go opposite that 15 degrees to the 10.2, and then we're going to go over our hypotenuse, or sorry, over our adjacent. Sorry, we're using tangent, so it's opposite over adjacent, over our adjacent, which is X. So you should get tangent of 15 degrees is equal to 10.2 over X. All right, and then we're going to solve for X there. So the way I did that was I multiplied both sides by X. All right. So once you multiply both sides by X, you should get X times the tangent of 15 is equal to 10.2. And then, of course, now we want to get the X by itself, so we just divide by the tangent of 15 degrees. All right? So therefore, your X is equal to 10.2 over the tangent of 15. So let's do that together. Why don't you type that into your calculator? 10.2 divided by the tangent of 15. And hopefully, when you do that, you get the same answer as me down there at the bottom, 10.2 divided by the tangent of 15, which gives us 38.07. All right, and here 38.07 is a side length, so we need to add on our unit of measure, which is feet. Okay? All right, so I'm going to show you what I got here, so you can just copy down. If you didn't see this, let's see here. You can kind of see on this side. I can't even show you. There you go. Well, you can see it's over here. Whoop, there. Tangent of 15 degrees is equal to 10.2 over x, which is equal to x tangent of 15 equals 10.2. All right, cool. Let's go on to the next one. Hopefully you already saw the answer actually on this one. But here we're going to do, again, the same thing as we did before. So you see that we're looking for QR. All right, so QR is what we're looking for, so we call that x. Okay, so label that x. All right, then we look at from the angle it gives us. So on this one it gives us 63 degrees. All right, so that x is opposite the 63 degrees, so we have an opposite. And then that 12.9 you'll notice is opposite the right angle, so that means it's at the hypotenuse. So we have an opposite and a hypotenuse. So let's think back to our SOHCAHTOA. So if we have an opposite and a hypotenuse, sine is opposite over hypotenuse, which, perfect, that's what we need. So we're going to use sine here. So we do the sine of the degree that we have, so sine of 63 degrees is equal to the opposite, which is going to be our QR, or we call x, over our hypotenuse, which is 12.9. So you'll see, now we have sine of 63 is equal to QR over 12.9. And now all we have to do is solve for our QR, or x. So we're going to multiply by 12.9 on both sides. So we get that QR is equal to 12.9 times the sine of 63. So we do that together. 12.9 times the sine of 63. Okay? And you should get 11.49. 11.49 there when you type that in. All right. And you'll see we need to add a unit of measure there. So the unit of measure on this one is centimeters. Centimeters. All right, cool. So again, I'm going to show you this, so hopefully you can see it and copy it down if you need it. So that's the one in the middle. We're looking at the middle B there. Okay, on to C. So on C, we're looking for FD. So again, you can label FD X, because that's what we're looking for. All right. So here, from the angle that it gives us, so it gives us 39 degrees, we look and see that x is the hypotenuse, and then 20, the other side that it gives us, is adjacent. So here we have an adjacent and hypotenuse. So let's think back to our SOHCAHTOA. So SOHCAHTOA gives us cosine is adjacent over hypotenuse, so therefore we're going to use cosine. So we're going to do the cosine of the degree we have, so cosine of 39 is equal to adjacent over hypotenuse. So our adjacent there is 20, and over the hypotenuse there, which we just called x, or you can call it FD. Either one is fine. All right. So then again, all we're doing is solving for FD, so let's multiply both sides by FD. All right. Once you do that, that leaves you with FD times the cosine of 39 degrees equal to 20. And then, of course, to solve for FD, we just divide by the cosine of 39. So altogether, we get FD is equal to 20 divided by the cosine of 39. So 20 divided by the cosine of 39. All right, so 20 divided by the cosine of 39. Hopefully, you are getting the same answer as me, 25.74. And again, this is a side length, so we need to add our unit of measure, which is meters. All right. So again, you want to check to make sure all of your answers are logical, of course. So we got that our x, which is the hypotenuse, is 25.74 meters. So we need to check to make sure that is greater than our other side that we have. So the cool thing here is it is 25.74 is greater than 20. But, you know, if your answer doesn't match up, that just probably means you did something wrong, so go back and check it out. So finally, we're going to finish with example 4. So this problem is exactly a triangle. All it is doing is adding words to it, trying to throw you off. But it's exactly the same thing. We can't be tricked. So let's read this out for it. So the Pilotsbahn in Switzerland is the world's steepest cog railway. Its steepest section makes an angle of about 25.6 degrees with the horizontal and rises about 0.9 kilometers. To the nearest hundredth of a kilometer, how long is this section of the railway track? Okay, cool. So the wording may be a little bit confusing, but whenever it says something with the horizontal, what I like to do first is draw a horizontal line. All right, so just draw a horizontal line there. And then you're going to make an angle with that horizontal up, because of course the railway is going up. All right, so it rises at a 25.6 degree angle. So you're going to have your railway rising at a 25.6 degree angle. All right. And it rises about 0.9 kilometers. So that means that one of the legs, the one that goes up, is going to be 0.9 kilometers. So when you figure out your triangle, it's going to look something like that. You see my triangle there at the bottom? And just 25.6 degrees and then 0.9 on the other side. So here, we are trying to find how long the railway track is. And of course, the railway track here is the hypotenuse, because that's where the train travels. It's kind of a tongue twister. So that's where the train travels, so that's what we're trying to figure out. So whatever we're trying to figure out, we always call x. So here we see that we have the hypotenuse, which is our x, and then we see that the 0.9 is opposite the 25.6 degrees. So we have an opposite in hypotenuse. So again, with our saw, katoa, we see that sine is opposite over hypotenuse. So we're going to use our sine here. So the sine of 25.6 degrees is equal to opposite, which is 0.9, over our hypotenuse, which is x. All right, so you should get sine of 25.6 is equal to 0.9 over x. All right, so then all we gotta do again is just solve for x here, so multiply both sides by x. So that gives you x times the sine of 25.6 is equal to 0.9. All right, hopefully you're with me there. And then of course we have to solve for x, so we are going to divide by the sine of 25.6 to both sides. So we get x is equal to 0.9 divided by the sine of 25.6. So why don't you do that with me? 0.9 divided by sine of 25.6. So hopefully you got something like that. So I believe I get 2.08. All right. And it says that we're in kilometers here, so 2.08 kilometers. And again, I'm just going to check my answer for reasonableness. Is 2.08 greater than my rise, which is 0.9? Yes, so that at least is a logical answer. So I'm going to give you this, show you this, and so you can just check it out here. If you need to copy it down, I'm going to give you a few seconds to do that. So you have about 20 seconds here. Okay, hopefully you got all of that. So that is the end of our lesson today. We'll see how we liked this kind of method of teaching, since I'll be out a fair amount in the next couple of weeks with tennis tournaments. So anyway, you'll see that your homework is on the board. I believe it's 11 problems or something of that sort. So if you get it done today, which I would hope you would, you can turn it into the basket. Again, do not be on your cell phones. You can just put your headphones in and be listening to your music as long as you're not on your cell phones. You will need your calculators a lot for this homework since you're using sine and cosine. So anyway, I miss you guys. I hope you're having a wonderful day, and I will see you on Wednesday. Bye.